Hello to you all. Today I'm going to be talking a bit about climate change and some implications for agriculture, specifically wheat in the Western Cape, Ruens area. This is the climatology or historical climate of Riversdal. The red line is the maximum temperature, the green line is the minimum temperature, and the blue bars are the rainfall. So clearly you can see that it's a winter rainfall region, although the highest rainfall is actually in April. The bulk of the rain falls between March and October. There is, however, some rainfall around the end and the beginning of the year. It's just important to keep this in mind when we look at the possible changes in the future. It's interesting to see that there is a drop-off in July and it picks up again in August. Many people will ask why the rainfall is higher in winter, and we do know that it's got to do with the climatic situation. And here we have an image from summer, February, and you can see a high pressure cell sitting there. And the high pressure cell is effectively rotating anti-clockwise, so winds are coming in from the east over the southwestern Cape. But also we see that it's blocking the frontal systems that are passing to the south of it. And generally speaking, we find that the far western Cape has got very dry summers, but the southern Cape, because the high pressure cell is situated to the west, allows some moisture to come in from the ocean, and so there is some rain in the summer months in the southern Cape. This diagram, a synoptic chart from August, gives us a better indication of what happens in winter. The high pressure cell is given away, and the frontal systems are now mostly free to come into the Western Cape and bring the rainfall. So the Western Cape is essentially a winter rainfall region, and the high pressure cells give way and allow these frontal systems to come in and bring the rain. And together with the rain, obviously there's a decrease in temperatures because these are cold fronts, and you can see they extend quite far south and bringing cold air in. Something that we also associate with winter, especially in mountainous regions, is snow. And snow is an added benefit because it stores water up that will later melt and be used in dams and irrigation. It's not particularly helpful for the wheat, but it does add to the long-term storage dam situation. One of the big questions we have to face is the issue of climate change and the impact on agriculture, specifically on wheat. We do know that the temperatures are rising. We do know that the climate's changing. I'm just going to briefly touch on the fact that climate is changing and then have a look at some of the impacts on the wheat sector in the Western Cape. The reason that the temperatures are increasing is that atmospheric carbon dioxide, as shown in this record in Hawaii, has been increasing over the last many years. This indicates a change that doesn't seem likely to stop, and this atmospheric carbon dioxide is as a result of human activity. An increased carbon dioxide in the atmosphere means that the atmosphere retains more heat, and this makes the planet a warmer planet. Now, some of this heating is created from electricity generation, some from transport, and some also from agriculture. The agriculture contribution in South Africa is quite low, but mostly it's from land and forest clearing, where otherwise natural vegetation would have absorbed carbon dioxide, and this is replaced by seasonal vegetation, which doesn't absorb as much carbon dioxide. And then cattle also release methane, and methane is a greenhouse gas. So these increased levels of carbon dioxide and methane are leading to global warming, leading to increased temperatures and changes in rainfall. Now, we've already recorded some of the changes of temperature in the Western Cape, and here you can see two graphs. One is maximum temperature and one is minimum temperature over the last 40 years. In fact, the graph only goes to 2005, but you can see that there's a trend of increasing temperatures. So this is undeniable, the fact that the planet is warming, the fact that it's going to continue to warm, but what we don't know necessarily is what's going to happen to the rainfall. The temperature is much more certain than the rainfall future. This is supposed to be an animation of the temperature at the end of the century and how it's going to evolve till then. But what we see is that by the end of the century, many places across the planet are going to be up to 5, 6, or 7 degrees warmer than they are now. And this is the kind of world that we're going to have to get used to and try and see how we're going to adapt to these temperatures. And clearly you can understand that agriculture is going to face very severe challenges. But next we're going to have a look at the situation with rainfall. So one of the things we can do is look at what's happened to the rainfall in the last, let's say, 100 years. And this is a graph of about 90 years of rainfall. And it shows the area in the Western Cape where near Cape Town, so it's more centralized around Cape Town near the dams there. But it shows the years progression, and the blue years are the years, the blue dots are the years that are above normal rainfall, and the red dots are the years that have had below normal rainfall, and then the white dots are those that have normal rainfall. So there's a natural spread of years that have more rainfall and years that have less rainfall. In the green box, however, we look at the last 30 years, and we see in the last 30 years up to 2018 that only 10 years were above normal, whereas 14 were below normal. Now, this is not necessarily of concern, but it does give us an indication that perhaps our rainfall is getting less. Perhaps our rainfall is reducing. Perhaps we should be expecting less rainfall. So we're going to interrogate some of the scientific models to see what they project specifically for the Southern Cape. The Southwestern Cape, or the Western Cape around Cape Town and the Swartland area, is showing a definite tendency towards drier winters. But let's see what they say for the Southern. So this is a fairly complicated graph of predictions for rainfall for Riversdale for the period of 2040 to 2060, so the middle of the century. And what we see here are grey bars and then blue and red bars. So the grey bars are the actual recorded, observed rainfall figures. So you'll see that, as I showed you previously, there's a peak in April. It drops again into a less rainfall in June, then picks up towards October, and then drops down during the summer. Now, the models that we used, and there are about 12 models, and they project what the rainfall might look like by mid-century. And they are then summarized by the blue and the red. The blue bars will show the models that are indicating it's going to get wetter, and the red bars show models that are indicating it's going to get drier. Now, clearly, we don't really have a clue about what's going on, because every single month there are red bars and blue bars. So it's best for us to say nothing about increased rainfall or decreased rainfall, except to say that it's very, very uncertain. So we've got absolutely no prediction for rainfall for the Southern Cape, other than to say that the models, although they don't agree, many of them do show expected changes. And the only month where we can really look and say where most of the models are saying an increase is in January. But it's not very helpful, because that increase is only about 5 or 6 millimeters. Let's move now and see what happens with the temperature. Now, when we look at the temperature, I've taken out the observed temperatures. This is the maximums. And what I'm showing here is whether the models are showing increasing or decreasing temperatures for the middle of the century. Now, all those red bars are showing increases. There's not a single model that is predicting a decrease. And that shows the span of the increase. So, for example, in January, it looks like the temperature is going to be increasing by just under 1.5 to 2 and a bit degrees on average in the month of January. And you can see this kind of average is spread throughout the year. October is seeing a slightly higher increase, around up to 2.4 degrees warmer. But some of the models are saying as low as 1. But there isn't a single model that's saying it's going to get cooler. And all of the models are saying it's going to get warmer. You will see one model line that is very, very high. And we tend to ignore that as an outlier. But it does give an indication that the heating could be more than we expect. So as I said before, trying to project the rainfall for the Southern Cape is very, very tricky. And anyone who tells you that it's going to be such and such, it cannot be telling the truth. So what we've created here is a 3-monthly summary showing you the wet models at the top row, the dry models in the bottom row, and the averages in the middle. And what I've done is trying to create a range of the expectations. Now, these are for 2035 to 2055, which is a 20-year period, using some slightly different models to what you saw before. This, in fact, are the latest models. And I've summarized it by the figures at the bottom. So if we look at the first column, which is DJF, that's December, January, and February, and we're looking at the area within the red circle, then you can see that the range of projections, if we look right at the bottom, there are models that are saying it's going to be dry, but there are also models saying it's going to be wet. And the range for those 3 months is between 15 millimeters less to about 5 millimeters more. And if one looks in the central column at the average, you can see that it is very slightly drier, expected to be slightly dry. Now this is different to what I said before, but this is giving us a range, and none of these are exact and none of these are accurate. We have to accept that there's going to be a range. But of more concern is March, April, May, and that's the second column. Here we see that certainly you can see in the Western Cape that it's bright red, and along in the Eastern Cape coastline it's also bright red. In the middle it's kind of an orange color, so we're looking at a range of between 15 millimeters a month less to 10 millimeters. Now this is per month, so for each of those 3 months, March, April, May, we're expecting a range of change from 15 millimeters less per month to about 10 millimeters more per month. And once again, the average is showing slightly less rainfall. In midwinter, June, July, August, which is the next column, you can see this range shifts slightly. We still have some projections saying it's going to be drier, around 10 millimeters lower than normal. But if you look at the top row, you can see there's more green along the South Cape, and the average, in fact, is positive. So we are expecting slightly more rainfall in winter if you look at the average. But once again, because it's a range, we certainly can't say for sure. The last column is September, October, November. This is the end of winter going into summer. And you can see it's quite similar to the middle of winter. We have a smaller chance of drying, minus 5 millimeters, and the wetting or the increased rainfall up to plus 10 millimeters. So this is all we're prepared to say. And you might say, well, it doesn't really tell us very much. So the message from this set of diagrams is that we are unclear and that the future rainfall for the area is uncertain. So this slide just summarizes the Western Cape projections. We're looking at severe increases in annual temperature. But the rainfall anomalies, which is the changes in rainfall, show large uncertainty. So to summarize then, we're looking at an uncertain pattern because we're looking at increased temperature, which causes more evaporation, and then possible extremes with droughts and extreme rainfall events. So that's quite broad. And when we say that extreme events are more likely, what we have been seeing in the data is that when it does rain, we seem to get the rain in more intense circumstances, so it rains over 1 or 2 days instead of over a week. And we're also seeing higher frequency of dry spells. Now, a dry spell doesn't necessarily make a drought, but a dry spell, if it's extended during the growing season, certainly it is a problem. Now, this diagram isn't really applicable for the Southern Cape, but there are similar diagrams that show drought in the Southern Cape. This shows a drought in the Swartland region, exactly the same time, but 2 consecutive years, 2002 and 2003, and there are many examples of this. And certainly the wheat growing regions are used to droughts. They're used to what we call bad years and good years. So we know that there is a certain variability within the system already, and farmers have learned to cope with that. So that's not really the issue. The question is, are these going to become more severe or more common? So once again, what we've got here is a slide showing the projections, but this time it's showing hot days over 32 degrees. So the gray bars, once again, are what the historical record is showing us. And for example, in January, it shows that there are around about 4 days over 32 degrees. Now, January is not really the growing season for wheat farmers, and neither is February. So we look at the months March to November, and you'll see that on average there's around about 1 to 2 days over 32, and we do see some of those days occurring in May, August and September. Not very many, but they do occur. Now the red bars show us what those increases are likely to be. None of the models are saying that the numbers of hot days are going to decrease, but all of the models say that the number of hot days is going to increase. So if we look at the growing season between April and October, we see that the number of hot days over 32 degrees is increasing by at least 1 day per month during that period. Now, this may or may not be a problem, but it's what the data is showing. So we need to be able to expect that. Now, because many people will say that 32 degrees isn't really a problem, We've also extracted the information for 36 degrees. And here you see that there are some models that are showing a decrease in the number of days that are going to get over 36. Now, we don't know exactly why, but this could be because of increased cloud. It also relates to some of the models which are saying there might be an increase in rainfall. You can see, though, that one month is a particular concern, and that is April. We already have an incidence of days over 36. Not many. On average, it's about a quarter of a day per month. But this is going to increase fourfold by up to 1 full day per month. Now, that again may not be a problem, and it's a question we have to ask ourselves. Is this going to affect the soil? Is it going to affect planting? Is it going to affect the wheat yield as a whole? Then again, we look down in November and December, and you can see there's a slight increase in these very hot days. Now remember that the Southern Cape is not particularly known for its very hot days. So the 36-degree graph may not be applicable, and as we see, there aren't many days. If you go to the Swartland, this graph really gives people a fright because there are a lot more hot days there. So the Southern Cape is actually probably doing a little bit better. Now, there has been some research done into modeling wheat, and this is very, very complicated. And what we've got here is two different types of models that are really looking at the long-term scenarios for wheat. So what you've got on the left-hand side is the baseline. This indicates the kind of yields that we expect currently. The middle the middle column shows you the situation in the future, and the third column shows you the change. So if the change is green, it means that in those places we're expecting the wheat yield to increase. If the change is yellow or brown, we're expecting the wheat yield to decrease. And in the Southern Cape, you can see that the models don't necessarily agree. The top model, the DSAT model, says that the yield is likely to increase, and the bottom one says the yield is likely to decrease. And this is the problem with agricultural modeling. And one of the main reasons that they don't agree is because the way you deal with it, the farm management, the systems that are applied are so different, and they will affect the yield much more than the physical rainfall or temperature. Now, to build on that, let's have a look at an analysis of wheat farmers. We know that we've got commercial wheat farmers, we've got small-scale wheat farmers. We know that yields vary from 4 to 5 tons per hectare, and some farms only get 1 to 2 tons of hectare. I spent some time in Australia, and in the southern parts of Western Australia, if they get 2 tons per hectare, they're absolutely ecstatic because their soils are so poor. But in South Africa, it's not uncommon to get 4 tons per hectare if you are an efficient commercial farmer. What we do also have is 2 ways of farming, and there are still some farmers who do monoculture and only farm wheat and do it very, very well, and they make a lot of money in a good year, but then they lose money in a bad year, and overall they still manage to survive. Other farmers have found that a bit risky, and they've diversified. So what they do is, if there is a dry year, they've developed some sort of other activities that they can focus on that aren't so susceptible to rain, or they use the little irrigation water that they have on some sort of cash crop. What we are seeing, and this is where research is leading us though, is that conservation agriculture is really, really important. Minimum till is saving soil moisture, it is saving yields, and there's much research, and you'll hear much of that, much more about that in this seminar day, in this Farmers Day, from other people. And the options that they're looking at is alternative crops, looking at crops that might require less water or that won't have such an devastating financial impact if the rainfall is very low. And then we do see the integration of livestock as being very, very important into the system. And then there are some people who are saying, I'm going to make a real boutique kind of wheat. I'm going to cater for people who are prepared to pay more. And that is also one option that we have been seeing. So we do know that South African wheat production doesn't cater to the demand, and we have to import wheat. And some people have said, well, maybe we should just be importing all our wheat, and maybe wheat farming isn't the way to go. And there's a lot of discussion about that. But if one looks as a whole at Africa, there's some positive things and some negative things. Essentially, maize consumption is decreasing. So we know that African people on the whole are moving away from maize, which used to be a staple crop, and the demand and consumption of wheat is increasing. And this is not necessarily a bad thing, because wheat has got a higher protein content than maize or rice, and that's good. But there are some warning signs about the development of wheat, and we've seen nutritional value of bread, even though the yields of wheat have been increasing, but the nutritional value is decreasing. And some reports have said that the nutrient content is down 30%. And we also know that commercial bread is pretty much not very good for you. There is a lot of negative publicity around bread, and if you look at the contents, it certainly makes you wonder whether you are eating more chemicals than you're eating wheat. Now, there are other complications, that the price of bread itself is a political issue, and nations have risen and fallen on the price of bread. And the price of bread, because it's a staple food, has to be watched. I'm not saying it must be controlled, but it has to be watched, and that can have feedback onto wheat producers, and that's very important to consider. If we look at Africa as a whole, it might surprise you to see that there are many countries that produce a lot more wheat than South Africa. And in fact, if you look at the list of production, South Africa only comes in the 6th highest producer of wheat on the African continent. And these other countries, interestingly enough, have increased their production massively by focusing on wheat and encouraging wheat growth. And this is because they see the trend from maize or from other crops towards wheat. So that's quite important. Anyway, in the map there you can see the major wheat producing countries in Africa. This graph confirms the trend of maize consumption and the increase in wheat consumption over the last 20, 30 years. And you can see the maize consumption, while it's not significantly decreased, has stayed pretty constant, but the wheat production is, well, the wheat consumption has risen quite steadily. And this means that the demand for wheat must surely be on. And here we see those demand curves. All of Africa, you can see the yellow graph is the demand for wheat, and the green is the production. So there's definitely a gap, and Africa needs to import. And we look at Sub-Saharan Africa, that gap is even bigger proportionally. So African farmers produce only 44% of the wheat consumed on the continent. So there is a demand for wheat. So the question is, can wheat still be an effective and productive and profitable operation in Africa, and specifically Sub-Saharan Africa, and specifically in your region? So I can't tell you whether you must carry on farming wheat or not. I'm not a wheat farmer, but what I can say is there are certain challenges that you're going to have to face, and certain opportunities. And one of the opportunities is smart agriculture. And we have some very, very smart people doing smart agriculture and also showing you how to do smart agriculture. And some of those people will be presenting to you at the Farmers' Day. So the suggestion is to follow the trials, follow the latest science, and see how you can benefit from that. There are also challenges. We know that land reform issues, access to fallow land, may or may not lead to increased agricultural production. We hope it would lead to increased agricultural production because the country needs agriculture. We also see the threatening encroachment of urban growth into agricultural areas, possibly not so much in the Southern Cape, but certainly in the Western Cape, and also some questions around support services. Agricultural extension isn't what it used to be, and we need to find a replacement for the original agricultural extension that used to be around. And fortunately, there are people stepping up to the plate to offer that. There are certain questions around pests and chemicals that might have to be changed. We know that temperature and rainfall will affect the range of pests. You'll hear about breeding rates. You'll hear about the spread of different pests according to temperature and rainfall changes. And then obviously the consumers who are saying we prefer fewer chemicals to be used in agriculture, and this is a challenge for you. The other challenge for farmers, I think, is also access to climate information. I'll be presenting a little bit about the next few months, but is climate change information and seasonal climate information accessible to farmers? And it hasn't been as good as we'd like to see it, and we'd certainly like to work with you on changing that. So from our perspective, we see certain questions for future research for the wheat industry. We're asking whether a green revolution in Africa is a positive development, whether there is a new revolution for wheat, how that will go, where that will go, and where it will lead farmers like you. We're asking how climate change will continue to affect wheat production and food security as a whole. Is there an opportunity for wheat farmers to expand? Is there an opportunity for wheat farmers to increase their yields, to cement their place in the Southern African production system? And specifically, can wheat agriculture be sustainable and climate-proof in the Western Cape? Are there ways of adopting different techniques to make sure that our wheat production is sustainable? Will it be able to sustain more livelihoods than it currently does? It's an important economic question. We know there are small-scale farmers that are looking to go into wheat. We know that wheat can be fairly labor-intensive, but it is mechanized. How does this affect the support of livelihoods? And then lastly, what part can government and research institutes play? Are they willing to play a part? Are they interested in playing a part? And how can we get to them so that we're both working on the same side towards developing our wheat industry? So if someone was to ask me my opinion, and I'm not a wheat farmer, but having a look at the climate scenario, having a look at the wheat industry as such, I would certainly say, since the wheat demand is not going to diminish in the short to medium term, and the increase for designer breads, if you like, and designer wheat is going to increase, I think we must focus on more food, better food, and making that food more accessible to people. And the question we have to ask ourselves is, how does this apply to wheat investment and growth? And I think we must look at the big picture. We must look at how to look after our soil, how to look after our water, how to look after the integrity of our farming system, so that we farm well, we farm safe, and we farm efficiently. And I think this is the future of wheat farming. And as I said before, you will hear from some very smart people working for the Western Cape Department of Agriculture that are very keen to help you with this. So to end off, as I promised before, I'm going to talk a little bit about the late winter forecast, the situation ahead, and although August will almost be over by the time you get this, and you'll learn a little bit more. This is a map from the University of Pretoria, which personally I find has very good value because it has what we call skill scores, which are the small graphs on the right-hand side. But let's look at the main graph, or the main map, which is August, September, October rainfall. And it is showing for the Southern Cape, where I've got the red arrow, that there is likely to be above normal rainfall for these 3 months. And if you look at the bars on the right-hand side or in the middle of the slide, you can see we're looking around about to 55 to 60% probability of being above normal. And that's a fairly high probability of being above normal. But the question now is, that's just a probability. There is still a chance that it'll be below normal. And this is where we find the skill scores very useful. So the skill scores have looked at this history of this forecast, and this forecast has been used, not being applied over the last 20 years, but they've done models where they've run the forecast for the last 20 years and compared it to the actual rainfall. And then they compile what we call a skill score. Now in the skill scores on the right-hand side, we only look at the top one because that pertains to above normal rainfall. The bottom one talks about below normal rainfall, and we haven't got that option. But you'll see the Southern Cape is mostly blue. And if you look at the legend, it's very small, it says that that is less than 0.5. So the skill of this forecast is not very high. If you happen to be in the yellow or orange regions, the skill is a little bit higher. So essentially what we're saying is, while we have issued a forecast and the forecast has some sort of a signal which is saying that it's likely to be above normal, historically this forecast has not been very skillful. So we advise that you do not put too much trust into what this forecast is saying. Now you can look at the source forecast, which also says above normal, and you can other shorter term forecasts. The general feeling, though, from our statistical analysis of the season so far, is that this winter season for the Southwestern Cape is likely to be normal to above normal in terms of its rainfall. So that's the best we can tell you. We are certainly not going to put our heads on a block and say, listen, it's going to be very, very wet, and we advise you to monitor the progress of the season. The nice thing, though, is that we are not getting a signal to say that it's going to be dry near the end of the season. And that's about the best news that we can actually give you. So at this point, I'd like to thank you very much for your attention. I'd love it if you would get in contact with me if you have any further questions. I am available. I wish I could have been there to see you. and working ongoing with wheat production and also maize production in South Africa, looking at the impacts of climate change and also looking at the ways that farmers can deal with these impacts. But I do wish you all the best for the season, and I hope that you are all safe and will remain so. Thank you very much.